Lesson 21, Substitution and Two-Step Equations. Here's part 1. Substitute and evaluate. Let's go over one example, box A. In this problem, A will be equal to 3. So here we have the expression A squared. And since we know that A is equal to 3, instead of writing A squared, let's write down 3 squared. So here is 3 squared. Let's evaluate this. We know that 3 squared is equal to 9. Here's part 2. Find the square roots. And notice that it says, write only the positive root. Let's go over two examples, box I and box M. Here, the square root of 9 is 3, since 3 times 3 equals 9. And here, the square root of A squared is A, since A times A equals A squared. Here's part 3. Substitute, then solve for the unknown variable, which will be A, B, or C. First example, box Q. Here it says, solve for A. And notice that B will be equal to 4, and C will be equal to 5. So here we have the equation, A squared plus B squared equals C squared. So let's substitute 4 for B right here, and let's substitute 5 for C right here. Let's go to the next line. Here's A squared plus, here we have B squared. And since we know that B is equal to 4, instead of writing B squared, let's write down 4 squared. Here's the equal sign. And here we have C squared. And since we know that C is equal to 5, instead of writing C squared, let's write down 5 squared. Let's simplify. Here we have A squared plus 16 equals 25. Now that we substituted, all we have left is a two-step equation. Let's subtract 16 from both sides. Here we're left with A squared equals 9. And remember, we need to solve for A, and A is not by itself yet since we have A squared. So take the square root of A squared, and whatever you do to one side of the equation, you have to do the same thing to the other side of the equation as well. So take the square root of 9. The square root of A squared is A. Here's the equal sign. The square root of 9 is 3. So our final answer is A equals 3. Next example, box R. Solve for B. And notice that we're going to substitute 6 for A right here. And we're going to substitute 10 for C right here. Next line, we have A squared. And since we know that A is equal to 6, instead of writing A squared, we'll write down 6 squared plus B squared equals, and here we have C squared. And since we know that C is equal to 10, instead of writing C squared, let's write down 10 squared. Let's simplify. 6 squared equals 36 plus B squared equals 100. Now that we've substituted, let's solve the two-step equation. We can subtract 36 from both sides of the equation. Here we have b squared equals, and here's 100 minus 36. I can use stepping stones to figure out this answer in my head, and I know that 100 minus 36 equals 64. We need to solve for b. b is not by itself yet since we have b squared, so take the square root of b squared. Take the square root of 64, and on the last line, the square root of b squared is b. Here's the equal sign. The square root of 64 is 8. So our final answer is b equals 8. Our final example will look just a little different. Here's box U. Solve for c. And notice that we're going to substitute 3 for a right here. And we'll substitute 4 for b right here. Here we have a squared. And since a is equal to 3, instead of writing a squared, we'll write down 3 squared. Plus, here we have b squared. And since b is equal to 4, instead of writing b squared, we'll write down 4 squared equals c squared. Let's simplify. 3 squared equals 9, plus 4 squared equals 16, equals c squared. Now let's solve the two-step equation. Notice that we can simplify 9 plus 16, so let's make this our first step. 9 plus 16 equals 25, write it down, equals c squared. We need to solve for c. c is not by itself yet since we have c squared. So take the square root of c squared and take the square root of 25. The square root of 25 is 5. Here's the equal sign. The square root of c squared is c. So our final answer is 5 equals c, or c equals 5.